In this video, we'll take a look at notes on section 4.1, an introduction to angles. So taking a look at some vocabulary in this section, an angle is pictured at the right. We have an initial side of the angle. So an angle basically are two rays that are radiating from a center point. So the vertex is the center point. This side is the initial side. It's where the angle starts. Rotated counterclockwise, we have the terminal side. If you measure rotating counterclockwise, the angle is positive. You can also measure rotating clockwise. So if you rotate the other direction, there's another angle here. And this one is called the negative angle. So the angle itself is made of two rays. The initial position is the position of the first ray. The terminal position is the position of the second ray. The vertex is where they meet. If we rotate counterclockwise, we have a positive measurement. If we rotate clockwise, we have a negative measurement. So many symbols are used to designate angles. Among most widely used are certain Greek letters such as theta, phi, alpha, beta. Capital letters representing the vertex, angle A or simply capital A, and other literal symbols such as X and Y are also used commonly. So most of the time, if we have this named by a point, A is the point where the vertex is, we would call that angle A. We can measure angles in a couple of different ways. Two ways we're going to focus on in the trigonometry section. The first one is in degrees. So degrees can be expressed a couple of different ways, but what a degree is if you take a circle and cut it into 360 equal pieces, 1 over 3/60th of the circle is 1 degree. So there are 360 degrees in a circle. So degrees can be measured with a decimal. If the degrees are measured with a decimal, something like 42.5 degrees, that tells you it's 42.5 of a degree. But degrees can also be measured in minutes and seconds. So taking this 1 over 360, 1 degree can also be expressed as 60 minutes. And 1 minute can be expressed as 60 seconds. So this is very close to our time, seconds, minutes, degrees. So that's another way to express a degree. So 42.5 degrees, half a degree, half of 60 minutes would be 30 minutes. So you could also express that degree as 42 degrees, 30 minutes. So we want to be able to use both of these types of measures, so we want to be able to convert between the two. Another way we can measure a circle is in radians. Radius, the definition of a radian is if you have a circle with measurement radius r, it's the arc. If you take this straight line measurement and measure along the arc, it's the angle, 1 radian is the angle cut by an arc that's the same length as your radius. So radians, a full circle, there are 2 pi radians in a circle. So the radian, 1 radian, why would we need radians instead of degrees? Radians are whole numbers or real numbers. So we use radians when we want real numbers. Degrees are splitting the circle into 360 pieces. So radian, 360 degrees is equal to 2 pi radians. So that means half of that, 180 degrees, is equal to pi radians. All right, coterminal angles is the next idea in the introduction to angles. Coterminal angles are angles that have the same initial and terminal sides. So a coterminal angle, example 1, determine the measures of two angles that are coterminal with an angle of 145.6 degrees. So this angle from here to here is 145.6 degrees. Coterminal means you could go around the circle another time take 145.6 degrees and add another 360 degrees, you're going to land in the same place. So this expression of 505.6 degrees is when you go around the circle a full time and then land on the same terminal side. So there are an infinite number of angles that are coterminal with this angle. You could keep adding 360 to get the positive, or if you want to go the other direction, you could take 145.6 degrees and subtract 360 degrees, and that way you'll be going in a negative direction, negative 214.4 degrees. So there are also an infinite number of negative angles that are coterminal. Just keep subtracting multiples of 360. So coterminal, the smallest coterminal angles would be the 505.6 and the negative 214.4, but you could keep going around and around the circle each direction. All right, so next example is how do we convert radians to degrees? So if we want to express 1.36 radians in degrees, then what we can do is we can use that conversion or proportion that you know that pi over 180, pi is the same measure as 180. This is radians. This is degrees. And we could set up a proportion equals x, let's see, 1.36 radians over x degrees. So that's one way to convert between radians and degrees. Use the fact that pi and 180 are the same and set up a proportion. Cross multiply, we get pi times x is equal to 180 times 1.36. Divide both sides by pi. Put the expression in a calculator. And I'm doing that real quick. We end up with 77.9 degrees. Okay, and use pi. Use your calculator. You estimate it with 3.14, but there's a pi key on your calculator, so you can use it not rounded. All right, next example. We want to convert 17 degrees 53 minutes to a decimal form using the fact that 1 degree is equal to 60 minutes. So we're going to keep the 17, and we're going to have 17 point something. So if we have 53 minutes and 1 degree equals 60 minutes, to find the decimal part, that's 53 out of 60. So we take 53 and divide it by 60. And when we do that, we end up with 0.88. So our degree measure in decimal would be 17.88 degrees is the same as 17 degrees, 53 minutes. All right, what if we want to go the other way? The angle between two laser beams is 154.36 degrees. Change this to an angle measured to the nearest minute. So now we want that to be minutes. So I have 154 degrees, and then I want to know how many minutes 0.36 is. So to find out how many minutes that is, take 0.36 times 60 minutes, and that is equal to 22. So that would be 154 degrees, 22 minutes. So if you're going to convert minutes to a decimal, divide by 60. If you're going to convert a decimal to minutes, multiply by 60. All right, last idea in this section is just a definition of what standard position is of an angle. So now we're going to take the angle and we're going to put it on the coordinate plane. And if we take an angle and put it on the coordinate plane, it's said to be in standard position if the initial side of your angle lines up with the positive x-axis. And the vertex of your angle is the origin. then the angle is in standard position. So you can rotate it in the positive direction or in the negative direction. We just want the initial side to be on the positive x-axis. And if your angle lands in the first quadrant, it can land in the second, third, or fourth quadrant. It can also land exactly on the x or y axis, and those are called quadrantal angles. So here are some examples below. So the first one is a 60-degree angle lands in the first quadrant, 130 degrees lands in the second, 225 lands in the third quadrant, 340 degrees lands in the fourth quadrant, negative 120 degrees lands in the third quadrant, and we have a quadrantal angle because the 90 degrees lands right on the y-axis.